And if you are liking these solutions, please remember to like and subscribe. And other than that, let's get started. So as you can see, we have solved till problem 37, and today we'll like to solve maybe one or two problems depending upon how many problems we can solve, how fast we solve these problems, and we can start from there. Okay, so without much ado, let's go to problem 38. And problem 38, let's create a new Jupyter notebook. So let's solve problem 38. We'll call this problem 38 like that. And it's called pan-digital multiples. So I think we have seen pan-digitals before, but we'll see what is happening over here. So let's look at the problem. So take the number 192 and multiply it by each of 1, 2, and 3. So 129 multiplied by 1 is 129, times 2 is 384, and times 3 is 576. By concatenating the product, we get 129, 384, and 576. We call this the concatenated product of this and this. All right. So we have the concatenated product of this and this. So the same can be achieved by starting with 9 and multiplying it by 1, 2, 3, 4, 5. Okay, giving 91, 82, 73, 64, 5, which is concatenated product of 9 and this. All right. Oh, this is also pan-digital. 9, 1, 2, 3, 4, 5, 6, 7, 8. Oh, okay. Okay. What is the largest 1 to 9 pan-digital 9-digit number that can be formed as the concatenated product of an integer? Okay, so the largest 1 to 9 pan-digital 9-digit number that can be formed. So what is this? What is this? Okay, largest this, so it should start with a 9 something. Okay, by concatenating product of an integer, so this should be an integer, okay, with 1, 2, blah blah blah, where n is greater than 1, so we can't have this. So this is out. Okay. So we can write a couple of functions and then we can figure out how to solve this problem. So the first function we have to write is a function that takes a number and gives us something that is the closest thing to a pan-digital number. So let's try that. So that's a multiply concatenate. Okay, it takes a number that will look like n, which is an integer, and it's going to give an integer. Okay, so it's going to give an integer, and it's going to start multiplying. Okay, like we normally do, we take the string of this number and not now, it's not the right thing to do. Okay, so for I in range 1 to 10, okay, equals that, and we want to start creating a number that is bigger and bigger by multiplying by I. Okay, and okay, we will CUR NUM plus equals, we will add it to the end, I times n. Okay, if CUR number is greater than equal to, the length of this is greater than equal to how many are there? 1 2 3 4 5 6 7 8 9. So there are 9 numbers. So if it's that, then we are going to break here, and this should return an optional int. Something like that. Okay, let's see. Python typing optional. Okay, let's see. And optional. Optional x is union of x and none. Optional int, that's how it is. Okay, so this is correct, and I will return a none if we don't get a match. Otherwise it will return a number. It will return this current number. So break otherwise. So we are over here, and at the moment we will just return int of something like that. Okay, and then we will return none later. So let's say we do multi-column 5, multi-column 9. We have a type error. str like that. So we get this value 91827 blah blah blah. If we give 192, we still get this. But if we, so this is the right number, 192384576. So this is correct. But if we do 25, some strange thing like this, it will still give us some idiotic stuff. So we want to make sure that at this point sorted this will give a list, and this is if this is equal to do we have a 0? We do not have a 0. 1 2 3 4 5 6 7 8 9. If it is equal to that, then return. Okay, else return a none. So this is going to return a none. 192 now should return 192, should return this value. 9 should return that value. So we have a function that takes a number n and returns this value, the right value, if it actually finds a proper number. So we have that function figured out. The next thing we want to figure out is where do we stop. So basically the idea is we want to do for I in range 99 to 910 to 1000. Okay. Multi concatenate I. If multi concatenate I is not none. Oh, next we put temp equals that, and if temp is not none, we will print temp. Okay, so we have to figure out where to stop. And we have to figure out which one is the largest number. So it's pretty clear that if we start with a 9 over here, it should be a good thing. So let's say we start with 99 and we go down to 10 and -1, right? Nothing. 8. Okay, so how about 999 and 900? Nothing. 9. Let's try. Oh, wait, we do have something. This one, we have this, which is pretty big, and then we have decreasing numbers. Do we have even more things? 9999 9 to 9 like that. Nothing. I think this should not even work, because 9999 into 1 is that. 9999 into 2, it's more than 9 digits. So beyond this, it's like 10 digits and so on. So this is it. This should be the number. All right, so this one was pretty easy. Okay, that's it. So let us save this, and let's try to solve one more problem, because this one was like really very easy. Okay, so let us 38 shut this down and we'll create a new one. Okay, project Euler, archives, progress. Okay, 38. Let's try 39. Integer right triangles. If P is the perimeter of a right angle P is the perimeter of a right angle triangle. Okay, P is the perimeter of a right angle triangle with integral sides A, B, and C. That integral sides, so the sides are integers, there are exactly 3 solutions for P. P equals 120. So A plus B plus C is okay. So I need to take out my Oh, let me create a new. Is the number of solutions maximized? Copy. Okay. New. That's problem 39. Let's look at this. Let's look at this. This one should have some. This is called integer right triangles. Okay. And let's see, let's try to look at this and see what's going on. Okay, so let's do this. P is the perimeter of, what the hell is happening? Okay, so you have a right angle triangle that looks like that. Okay, and you have sides A, B, and C, and the perimeter P equals A plus B plus C. And for the right angle triangle, we know A square plus B square equals C square. So that's something that we already know. All right. So now for P equals 120. Okay, so if P equals 120, then A plus B plus C is going to be equal to 120. So we have to loop over A and B, and given A and B, we will be able to find C. All right. A and B. Okay, let me see. So if I talk about a perimeter P, okay, any perimeter P, then I can talk about C equals P minus C equals A plus B, right? Okay, or A plus B minus P equals minus C. That looks like the right equation to work on. Or I can work on this. I think I can work on this. If I square this, it's P square plus C square minus 2 times P times C, okay, equals A square plus B square plus 2AB. So that's good. C square is equal to A square plus B square. So we are left with this equation over here, P square minus 2pc equals 2ab. Okay. P square equals 2ab plus 2pc square equals ab plus pc. So this condition has to be satisfied. That's one condition that has to be satisfied, and can we reduce P equals A plus B plus C, right? So C equals A plus B minus P, or minus C. Okay, so if we continue, of P square equals A plus B plus let's see, half P square equals AB plus A plus B minus P times C. Wait, times P, and there should be a negative. Does it help? AB minus EP minus BP plus P square so this, when it goes over here, it will become a negative half P square AB minus AP minus BP. Is that a meaningful solution? So we have eliminated one thing. Okay, let's do a quick check to see whether this is correct. Let's do a quick check to see whether this is correct. So we are working with the formula minus 0.5 p square. So let me just write this down over here. Minus fraction 1 by 2 p square. Yeah, it's not equal to, so negative 1 by 2 p square equals AB minus AP minus BP minus BP. Okay, that's, let me just get this out of here and see whether this holds up for that 120. So if we say P equals 120, okay, P square by 2 is that, and A, B, and C are equal to 20, 48, and 52, right? So P square by 2 is that, all right, and AB, so A into B minus A into P minus B into P is equal to the same thing. Okay, so we have an equation where we just need to vary A and B, right? And we don't have to worry about the third number. So we just need to find integers. Yeah, so we just need to find integers that have this property, and we should be able to find it. So let's create a check, and we will provide two numbers, A and B, and B and P, of course. And so these are all integers. This is an integer, this is an integer, this is an integer, and this is going to return a bool. It's going to return a boolean value. Done. So we will create this value over here, that value over there. All right. If that equals minus that, okay, return true, otherwise return false. Okay, so that's an easy check. So for example, if you have check for 20, 48, right, and a perimeter of 120, then that's true. All right, so now we have to find a group of values like that, that will lead to 120. Okay, so let's see. For I in range, it has to start with 1 and needs to go up to, okay, so let's p minus 1. Okay, for j in range I plus 1, so two things cannot be the same number, otherwise there's square root involved, so that's why it's I plus 1 all the way to p, and that's it, right? If check I and j and p, print I, j and p minus I minus j. So we have 20, 48, 52, 24, 45, 51, and 30, 40, 50. All right, so all this is good. For which value of p less than 1000 is the number of solutions maximized? So one thing is for sure, p square by 2 has to be integral. If it's not integral, then it cannot be a solution. The other thing is, the only way something is divisible by 2, right, is if it's even. The square of this has to be even. So for p in range the smallest number I think is 3, 4, 5. So 3 and 4 and 5. So 3 plus 4 is 7. 7 plus 5. Should we start with 12? Okay. Let's put n. N equals 50. Okay. In orders of 2, and then p. Lots and lots and lots of things. Okay, stop. Oh, we had gotten pretty close to 1000. Wait, n is only 50. Okay. Okay. We had gotten pretty close to 1000. Okay. So starting off, we say that equals that, Okay. Equals that. Final result is none. So this is something where we'll say this is result dot append that. Okay, so this one will contain all the different ways in which we don't really care. Result is 0. Result plus equals 1. If result is greater than 0, okay, print. Let's just print it. Let's see which ones are. This is called P, and we will put a space of 5D. Okay, and this is going to tell us how many of these things are there. Result. Okay, and if result is greater than final result, okay, then final result equals result, and there is a problem. Oh, like that. Blah blah blah. It's 5 over here. Oh, 6. 720 has 6. Okay. 8. 840 has 8. Damn. Final result. I'm looking for final result. 8. There you go. 840. P equals 840. One, 2, 3, 4, 5, 6, 7, 8. 840. Is that the number? All right. So we have solved 2 problems in 39 minutes. I think both these problems are pretty simple. So I should say we will stop over here, and yeah, I will see you in the next episode. And again, if you like things like these, videos like these, then please remember to like and subscribe, and I'll see you next time. Bye bye.